They say seeing is believing. But imagine what you could believe if you could see better than the human eye. But how can you see better than the human eye? With the help of multispectral sensors. Hi, I'm Amelia Dalton, host of Chalk Talk. There has been quite a bit of advancement in the world of spectrometers over the last several years. In this episode of Chalk Talk, Jim Archibald from ams OSRAM and I investigate how multispectral sensing solutions are driving innovation in a variety of different fields. We also explore the functions involved with multispectral sensing, the details of ams OSRAM's AS7343 spectral sensor, and why smoke detection is a great application for this kind of multispectral sensing. And before we get started, don't forget to click that link. There you can find even more information about this topic from ams OSRAM. Hi, Jim. Thank you so much for joining me.
Thank you, Amelia.
Okay, so I'm excited to chat about spectral and color sensors today. But, Jim, before we get started, what is all involved when it comes to multispectral sensing?
For multispectral sensing, you need a couple of things, and there are a few steps. One thing you need is the object that you want to analyze, and the next thing you need to illuminate it, and then you're going to need some kind of equipment to do the spectral analysis. We typically look at it in three different steps. Step number one would be to measure the object in either ultraviolet light, visible light, or even infrared light. So you want to illuminate the target with that kind of light. Then the next thing would be to sense what's either reflecting off of the object, like if you had an apple and you shined light, broadband light at it, the red would be reflecting off of you. So you're going to want to measure that somehow and obtain a spectral signature. Sometimes light will travel through a substance, and so that's a transmissive measurement. But once we do step two and we've obtained the spectral signature of that object, then we go to step three, where we can make a decision to either monitor what we're seeing or adapt our system or control or notify someone, hey, this apple's too red or not red enough or whatever. So those are the three main steps.
Great. Now, there has been a lot of innovation in the world of spectrometers in the last several years. So, Jim, what kind of cool stuff can you do with one of the portable ones today?
Yeah, it's quite exciting because these things have gotten so miniaturized. And with ams OSRAM, we've shrunk it down to the size of an integrated circuit. So we're able to do color measurement. You can do quality control or security measurement. For instance, if something's coming off an assembly line and you want to make sure that is the color pink that we want it to be, you can do that kind of quality control. You can calibrate the display like on your computer. When you look at those colors, is that really the right coloring? Does it look like the object looks in real life? So you can use spectral sensing to calibrate a display. You can totally improve the online shopping customer experience and make sure that people get what they think they're getting so that they don't do so many returns of objects that are like, wait, this is totally the wrong color. Also for industrial and prosumer applications, you might want to automate things, maybe even automating turning on and off a sink. That is actually an optical measurement that can be done. For industrial and prosumer, you can do automation, disinfection, instrumentation, smoke detection, and performance monitoring. Those are all things that can be done with multispectral sensors. And then finally, another topic within spectral sensing is constituent or condition analysis. For horticulture, for instance, you may want to monitor the light coming in to make sure that it's the right coloring of light that makes the produce flourish. Or you could look at fruit freshness and determine, is this fruit ripe or ready to sell? Also, you can use spectral sensing for anti-adulteration or safety monitoring. Is this wine or olive oil, is this really legitimate, or has it been adulterated or even contaminated? Also, you can use spectral sensing to monitor the quality of water to see what's in there, stuff that you might not see with the naked eye. And then also you can sense if an object is moist or not. If you do a spectral sense, you can detect that moisture in an object.
That's super cool. Now, Jim, what solution you need is determined by what range you want to detect. Is that correct?
Yeah, absolutely. So there are all kinds of subsections of the spectrum that you might want to look at. And so light is within the electromagnetic spectrum, but you may want to look at ultraviolet light. Perhaps you're interested in knowing if you're getting exposed to radiation that's going to cause you sunburn. You're certainly interested in visible light. That's what our two eyes are able to see. And we see all the beauty in the world and the colors and everything. Spectral sensing within the visible range is super important. And the more accurate that the sensing can be, the more it resembles what we see with our eyes, the better that spectral sensing is. And then there's even spectral sensing in the near infrared or infrared range as well. So they're all interesting, and you see the world in a different way depending on which part of the spectrum you're analyzing.
Okay, so in that visible range you mentioned, the AS7343 sensor, can we take a closer look at that one?
Yeah, the AS7343 is a new product from ams OSRAM, and that is a 14-channel spectral sensor. Here's a block diagram that shows how it works. It uses an I2C interface. You can see that there's a little circle with showing some of the colored areas on the die. And so the light hits the surface of the sensor, and we're able to detect these 14 different channels. Some of these are in the visible range, but also we have broad range and infrared, and even a flicker channel, which will detect flicker in the lighting system around you.
Fantastic. So, Jim, what kind of benefits does this solution bring to the table, and what kind of applications would it be a good fit for?
The AS7343 is what we call a multi-purpose spectral sensor because there are all kinds of applications that it can fit into. And because it has 14 channels, it really gives you a very broad view of the spectrum and what's going on. So some of the key benefits or features would be that it has 14 channels distributed over the visible range, including the XYZ color space. A lot of times we talk about the RGB color space, red, green, blue, and that's a great representation of color. But XYZ really mimics how the human eye sees. So this sensor actually has 3 channels, XYZ, in addition to some other visible channels. It also has a near infrared channel as well, so it can see things that our human eye can't quite visualize. And so the overall spectral range goes all the way from 400 nanometers up to 1,000 nanometers. And the AS7343 is cool because it has 2 special channels, what we call a clear channel, which sees the whole spectrum across the board. It's not broken into the little channels like some of the other previous channels I mentioned. And it also has this continuous flicker detection. So if you were using this in some kind of camera system or even in a computer or a tablet or phone, a lot of times if you have a camera, you want to make sure you understand the lights flickering and you can compensate for that. So this device even has a flicker detection channel. It has 6 parallel analog to digital converters for signal processing. So you're able to take a snapshot of any 6 of the 14 channels at once. So just 2 or 3 snapshots, and you've seen everything that you want to see with your reading. It uses the very standard I2C interface. So it's pretty easy to interface with a computer or any kind of MCU. And it's also got a very low profile, small package. So those are some of the key features. That's what customers seem excited about. It can be used as a general purpose spectrometer. It can be used for horticulture-based spectral sensing. It can be used for spectral smoke detection. In fact, it will even allow you to determine the signature of the smoke, like is that wood burning, or is it plastic, or is it vaping, or is it something else? This spectral sensor will allow for color matching and skin tone measurement. And it is so accurate. In fact, it is more accurate than the human eye. So it can be used for laboratory grade color, liquid, or reagent analysis. So lots of cool applications.
So, Jim, could you show me what a different spectra would look like with the AS7343?
Absolutely. The AS7343 filter definition is shown on this slide. If you look at the legend on the bottom, it's showing you the frequency, the center frequency for each of the different channels, starting at 400 nanometers and going all the way up to 850 nanometers for the near IR, for the center frequency. And then you can see in the plot above that legend there, it's showing you the overlapping different spectral channels. So it really does provide a nice sweeping view of the full spectrum across the range. On the right side, you can see the actual pattern of the filter elements over our photodiodes in the sensor. So those are the actual channels and how they're laid out on the die.
So, Jim, you mentioned spectral smoke detection. So, I'm really intrigued by that application. Can you give me some more details about it?
Yeah, we see the use case of a spectral smoke detector as really important. And some of the advantages are you want to be able to detect things rapidly and even identify or recognize the type of smoke. So some of the problems of smoke detection are the faster you can do a smoke detection, the more lives you can save. So that's very important, the speed of identification. But differentiation of smoke is becoming more and more important because knowing the type of fire versus is it a vapor or steam is very important because false alarms are expensive or endanger lives. And also smoke detectors have to work for a very long time. They stay in your house until the battery starts beeping. And so they have to be reliable over time. So the solution, as we see it, for improving smoke detectors is having a high sensitivity spectral sensor that can measure the light and the scattering of that light as it interacts with smoke particles. And so it can improve the smoke detection speed. So that's how the spectral sensor can help improve the smoke detector by being quicker. The spectral footprint allows us to distinguish between different smoke types and reduce false alarms. If it's burning bacon or someone is vaping, you don't necessarily want to overreact to that. So understanding what the spectral footprint of the smoke is really important. We see that the non-organic interference filters in our device, as I showed on that previous slide where I showed the different colored dyes, we use non-organic interference filters that are long-term, very, very stable, and they are immune to the effects of time and temperature. And they enable very accurate readings via a one-time calibration.
So, Jim, I wonder what the inside of that smoke detector looks like.
If you look on this slide in the upper right corner, this is the evaluation board for our spectral smoke detector. And you can see there's all these little maze-like structures in there. The idea is smoke and air can flow through this housing. And of course, we've taken the top off the housing, but air can flow through, but no light can flow through. All light is blocked. And then inside the structure here, we have several of our spectral sensors, and we also have two kinds of LED emitters. We have broadband white LED emitters and also infrared LED emitters. And so we turn those on, and then we're able to see the scattering and the reflection of the light on the particles that are flowing through.
So, Jim, can this solution differentiate between different smoke types as well? I would imagine there is quite a bit of difference between a wood fire and a plastic fire.
Yeah, absolutely. The whole point of using a spectral sensor is to see the differentiation of smoke types. We typically take readings from a spectral sensor in terms of counts. In other words, how many photons are reflecting off that section of the spectral sensor. And so you can see that we have four different materials, or the smoke of four different materials, and what the channel counts look like. So if we start on the left and just look at the channel counts, the Y scale, the vertical scale, is the number of counts. In other words, the intensity of the light reflecting off. On the far left, we're just doing a UV and a white and an infrared illuminator, and we're just testing the system to see what we see with nothing in there. Then the next one over, we have flaming wood, and you can see the reflections are getting bigger. We're seeing more interaction, more light reflecting. If you go to the third set of bar graphs, this is flaming plastic illuminating with UV light, white light, and infrared light. And you can see it looks totally different than flaming wood. So you would be able to read that and say, hey, something in plastic is burning. This is, we react a certain way for a plastic fire. And then just to make sure that the spectral smoke detector isn't fooled, we can see what happens when you put fog in there. And that spectral shape is a totally different footprint. And you can see that spectral shape is a totally different footprint from the flaming plastic or the flaming wood or just the bare bones test.
So, Jim, do you guys have an evaluation kit for this solution as well?
Yeah, and I already showed you what it looks like with the cover off, but this is the evaluation kit with the cover on. It has a smoke capture chamber. You can see there are ports on the side that allow air to flow through and get analyzed by the spectral sensor and the different emitters that are inside. So the dedicated AS7343 smoke detector evaluation kit includes the following. It has the customized smoke chamber. It has a dedicated GUI software for data display and evaluation of what you're seeing going on inside. And the kit uses the following ams OSRAM components. It uses the AS7343 multispectral sensor that I've been talking about. But I want to give a shout out to the other half of our company, which makes LEDs. So this smoke detector evaluation kit also has two OSRAM near IR LEDs in there to illuminate the smoke. And it also has two OSRAM white LEDs. So the illumination and the spectral sensing, the key components all come from ams OSRAM.
So, Jim, do you have any different versions of this kit available?
Yes, absolutely. So in addition to the smoke evaluation kit that I just mentioned, we have two other AS7343 evaluation kits. The one on the left is the standard evaluation kit if you want to analyze the light in a room. So you can see that it has a diffuser, the white circle made of plastic, and that's mounted right on top of the AS7343 aperture. And this kit is used to assess the quality of light in an ambient environment. For instance, you may go to the store and buy a light bulb that has 2700 Kelvin correlated color temperature. This eval kit here on the left is used to evaluate what is the spectrum of light and what is the correlated color temperature of the lighting that I'm seeing in my room right now. The kit on the right is what we call the reflective evaluation kit. And you'll notice it doesn't have the white diffuser over the sensor, but rather it has a little black plus housing over the sensor. What this one does is you can put the sensor facing down. Let's say I flipped over the circuit board and put it on the pink square underneath. It would illuminate the target, the pink square, and then the sensor would be able to read back the spectrum that it sees. So this kit is really useful for doing color matching and color identification and things like that.
All right, Jim, this has been super cool. Can you recap your main points for me?
Sure. So we're very excited about the AS7343 spectral sensor. It has 14 optical channels distributed over the visible range, including XYZ, and one in the near infrared. It includes 2 extra channels, one to look at the clear spectrum, and also a special channel to detect light flicker. It has 6 parallel analog to digital converters for signal processing. It has an ultra-low profile package. And just as a reminder, the key applications are this part can be used for a general purpose spectrometer. It can be used in horticulture. It can be used in a spectral smoke detection to tell you the signature of the smoke. It can be used for color matching and skin tone measurement. And the AS7343 can be used in a laboratory grade color, liquid, or reagent analysis.
Excellent. Well, Jim, I think that's all I have time for today. Thank you so much for joining me.
Thank you, Amelia. It's been fun.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from AMS OSRAM. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to EE Journal. You can't miss it. It's right across the top. Or check out YouTube, youtube.com/EE Journal.